So again, it's the same thing. So we have the circle, we have the measurement of arc A, B, C. We're following all of them. You're just adding these individual parts. So it's equal to the measurement of arc AB plus the measurement of arc BC. So that one's a pretty cool one. Very similar to just simple adding. Just keep that one in mind. Okay, so now moving on to the next one. We're being asked to find the measure of each arc. So here we are asked to find GE. So GE. So we're going to go this way. So with GE, we're going to be adding this measurement of GH plus GHE, and that's going to be 40 plus 80, which is 120. Okay, the next one is asking us to find GEF. So GEF. So it's adding all of these three. So 40 plus 80 plus 110 equals 120 plus 110, which is 230. Okay? All right, we've got a couple more. So now we're going on and introducing the theorems. So we have theorem 10.3 on your textbook. It's the congruent circles theorem. And this is what it's saying. It's saying that two circles are congruent circles if and only if they have the same radius. So we have two circles here. If they have the same radius here, then we can say that these two circles are congruent. Okay, it's a very simple one. Just keep that in mind. Radiuses are very important, and that's what they determine if the two circles are congruent. So next one here we have theorem 10.4, congruent central angles theorem. It says that in the same circle or in congruent circles, two minor arcs are congruent if and only if, this is the IFF means if and only if, their corresponding central angles are congruent. So look at it as the vertical angles that we've talked about earlier, right? It looks like a V here, two V's, here and here. So it's saying that the measurement of or arc BC is congruent to arc DE if and only if the measurements here, the central angles, are congruent to each other. So if this is congruent to that, then we can say that these arcs are also congruent. It's going to be a very important one as well. Then we got this one. So I want you to go ahead and with your partner, or in this case, you're going to go ahead and do it on your own. Tell whether the arcs are congruent. So they want you to, you were not supposed to see that one. They want you to determine if CD and EF, if arc CD and EF are congruent. So CD and EF, because the angles are congruent, then we can say that, just like here, we can say that these arcs are indeed congruent. Okay? So just by the theorem 10.4. Okay, we have one more. We have theorem 10.5, similar circles theorem. Very simple. It says all circles are similar because no matter what, you're always going to be comparing a smaller radius with a bigger radius. And just because of that, they're going to be similar. Think of these as kind of the scale factors that we did with triangles earlier, right? Their scale factors are, if one triangle is double in size than the other, we're going to say that they're similar, right? In this case, their radiuses it might be smaller or bigger than the other one, but it's no matter what, all circles are going to be similar, which is a really, really, really cool one too. And then the last one is actually just the exit ticket. So this is before you guys head out. I want you to go ahead and tell me which circle, so there's 4 circles here, which one does not belong. So looking at what we've just learned with radiuses and arcs, measurements, if this circle has a radius 6 inches, this one, the diameter is 1 foot, the diameter is 12 inches, and then the diameter here is 6 inches, I want you to go ahead and circle which one you think is, or cross off which one you think is not does not belong with the rest. In other words, which one does not have a congruent radius. Okay, so that's pretty much it for today, guys. I hope you were able to follow on with my lesson today, and if not, go ahead and review the video again, rewatch it, and I hope you guys have a good day. Okay, bye.